All right, part 2, because I hit the pause or the stop button. All right, so number 11, it says, consider this situation. You have a set of 4 suitcases that decrease in dimensions. You pack your 24 by 20 by 12 inch yellow suitcase. You are at the JFK airport in New York getting ready to board the plane to the LAX airport in Los Angeles to visit your cousins for spring break. The ticket agent asks to measure your bag. The question is, to bring the bag on the plane, the sum of its dimensions must not be more than 54 inches. Okay? So, is your bag too big to carry on the plane? Alright, so we have a 24 inch by 20 inch by 12 inch yellow suitcase. Okay? It says to bring the bag on the plane, the sum of its dimensions must not be more than 51. So, when it says the sum, you have to add each dimension. So, we have 24 plus 20 plus 12. A total of 56 inches. And it says it cannot be more than 51. Is my bag too big to carry on the plane? Yes, it is way too big. Okay? Now, this question leads to number 12. Hold on, it's loading. I live out in the middle of nowhere, so the Wi-Fi might be a little slow. Okay, there we go. This leads to number 12, okay? And it says, on Agile Mind, as a result of your flying experience, you decide to do a little analysis so you are not taken by surprise for your future trips. You want to take the bag with the largest capacity, but you want to be able to carry the bag on instead of checking it in. As the bags in your set of luggage get smaller, the 3 dimensions of each bag seem to decrease by the same amount. All right, what did I just say? Highlighter. As the bags in your set of luggage get smaller, the 3 dimensions of each bag seem to decrease by the same amount, X. All right. 2 things. Actually, more than 2 things. So we have a 24 inches in length. We have 20 inches in the width. And we have 20 inches of how deep it is. Okay? So we know from number 11 that the total linear inches was 56 because it asked for the sum. Okay? Now, if you look at this chart, it tells us the volume is found by multiplying the length times the width times the height. That is because the volume equals length times width times height. Okay? Now, we're going to have to find another suitcase because it is too big, right? So, same thing again. What I've already said. The 3 dimensions of each bag seem to decrease by the same amount, X. So, they each decrease. The word decrease in math means to subtract, right? They all decrease by the same amount, X. Do we have an exact amount? No, We don't know that exact amount, but we know that the amount is x. Hence, why it says 24 minus x, 20x, and 12x. Okay? These are my new dimensions. Okay? So, let's see. Write a polynomial function, L of x, which is total linear inches, to represent the total linear inches of any size bag in terms of x. Make sure to simplify your function rule. Okay? So this is the first measurement, the second measurement, and the third measurement. So if I want to find the total linear inches, I am going to have to add all three dimensions. Okay? Just like we did a couple minutes ago, we have to combine like terms. Okay? So, we have 24, 20, and 12. Okay? We know that is a positive 56. Now, we have to combine our x's. We have a negative x, a negative x, and a negative x. So we have 3 negative x's. So this is the same thing. I'm just swapping it around so it's in the correct form. Negative 3x plus 56 for our L of x. Okay? So now, I'm going to go back and I'm going to click check. And it's going to show you the exact same thing I did. You're supposed to add all three dimensions. Okay? Now, it says to graph it. So, on your paper, you are graphing this right here. Y equals negative 3x plus 56. It says you should recognize the type of polynomial function. Is it linear, quadratic, exponential? It's linear because it's y equals mx plus b. My slope is a negative 3, and my y-intercept is a positive 56. Okay? You can graph that in your y equals. All right, so here it is. It tells us it is a linear function, okay? The domain is all real numbers. We'll talk about domain in class on Thursday. So domain is x, so you read it from left to right. And then the range, does it ask about the range? No, it does not ask about the range yet. So we will talk about the domain on Thursday. It'll be easier for me to explain and tell you in person. All right, now, number 13. This time, it wants us to find the volume of the other functions. So for volume, it means to multiply. All right, so since you have 3 of them, first I'm going to take the first 2. Okay. And I am going to say 24 times 20 is 480. 20 times negative x is negative 20x. 24 times negative x is negative 24x. And a negative x times a negative x is a positive x squared. Okay? Now, I'm going to combine, but I'm going to write my highest power first. X squared. Oops, I forgot an x right here. X squared. Then I'm combining this box and this box to a negative 44x plus 480. All right. Now, taking this and I'm multiplying it by my last term. Why do you think I made 3 columns? I've been making 2. But this time I'm making 3 because I have 3 terms. I have a trinomial. X squared minus 44x plus 480 times 12 minus x. So, I have 12x squared negative 528x 5,760 a negative x cubed a positive 44x squared and a negative 480x. So I'm going to combine terms from highest power to constant. So we have a negative x cubed. We have a positive 56x squared. We have a negative 1008x plus 500 or 5,760. Okay? Now, I'm going to hit check, and it's going to show us the exact same thing that I just did. Okay? The same answer. Okay? It says, notice when you multiply 3 linear expressions, you got a third-degree polynomial. Polynomials of third degree are called cubic expressions. When you graph the cubic function modeling the expression, you got a shape that is very different from a linear or quadratic function. So, the graph on the right is what you need to do on number 13. So, you're simply going to type that in your y equals. If you don't have a calculator, you can go to Desmos and you can type that in and it'll show you the exact same graph. Or you can just sketch it. So, number 14. What type of expression do you get when you multiply 3 linear expressions? Cubic expressions, third degree polynomial. Alright, so I want to skip number 15, 16, and 17. And I want to go to 18. All right, 18 is almost exactly what we did just then. So I'm going to get you started, and then I want you to do it on your own. It's loading. I don't know if it's going to work. Let me go back. All right. On A, it says, what is the volume? Well, you're given 18 by 12 by 12. So remember the volume, you have to multiply. Volume is length times width times height. B is kind of like what we just did, except it says it is being increased by X inches. This time you have to know that increase means you add. Do we know the exact amount? No, it just tells us by X. and you have to find the new volume. So you have to make your new dimensions, and then you have to multiply to